elevation in boiling point. Next is your elevation in boiling point. This is also a colligative property. So before this, what is boiling point? We know that boiling point is that when the temperature at which a liquid boils up, that is what boiling point. But now onwards the definition will change, that the vapor pressure of a liquid, when the vapor pressure of a liquid is equals to the atmospheric pressure, the liquid starts boil. Okay, the temperature at which the vapor pressure of a liquid is equals to the atmospheric pressure, that is what? Boiling point. You can write temperature at which the vapor pressure of liquid is equals to the atmospheric pressure, that is what your boiling point. Okay, so if you plot a graph, temperature versus vapor pressure versus pressure, suppose this is 1 atmospheric pressure and you have one solvent. You started giving temperature, it increases, vapor pressure increase. But at a particular time it will reach the atmospheric pressure, and at this point it starts boiling. Okay, so this is what your pressure, this is what your atmospheric pressure where boils up. Suppose this is your TB naught, because this is pure solvent, we are not taking any solution. And again, now we are adding some non-volatile solute to that container. You are adding non-volatile solute to this. Okay, so what will happen? The presence of non-volatile solute, it will cover up some surface area again, so the vapor pressure will decrease. RLVP, we know that the vapor pressure will decrease, and what happens, the graph will be like this, because the presence of non-volatile solute, the vapor pressure, see this side x-axis, the vapor pressure will low, and when you increasing the temperature, it will take more temperature to achieve that boiling point. It requires more temperature to achieve that boiling point. So this difference is known as delta TB, change in temperature. Del signifies that change in temperature. Okay, so delta TB is equals to, is the difference between the temperature, and T naught B stands for pure, this is pure solvent, this is solution. Okay, that means this temperature, it depends upon what? Number of solute particles added, that is nothing but molality. So delta TB is directly proportional to molality M, or delta TB equals to Kb into molality. What is Kb? Kb is elevation constant. Or proportionality constant, or ebullioscopic constant. Okay, so what will be the unit of this? We know that the unit of temperature is Kelvin, and what is the unit of molality? kg per mole. Yes or no? So this is Kelvin kg per mole. The unit of kV is. So this equation can be written as delta TB equals to kb into molality is weight by of solute by given by my molar mass into 1000 by W1. So this can be a useful formula for you all for solving the questions. Some maximum time the question in the question M2 will be asking, and by putting this you can easily calculate okay. Note. Okay, let me clear this. Okay, so next colligative property is your depression of freezing point. Third, depression in freezing point. So what is freezing point? Again, the vapor pressure of liquid when at the temperature at which the vapor pressure of a liquid is equals to the vapor pressure of the solid. Okay, suppose you are plotting a graph, same graph, vapor pressure versus temperature, and you are taking a solvent. We know that as temperature increases, the vapor pressure increases. But will come this side because we are freezing it. Okay. So from higher vapor pressure, it will come down as we temperature less, or you'll start with 0, -1, -2 likewise. Okay, so liquid, this is the pure solvent, and this is the solid at minimum temperature, and this is the point where it forms a solid, freezes. Let's say this is TF naught. Okay, let's say TF naught. Now we are adding some non-volatile solute. Same thing, same process. Suppose this will be the vapor pressure of solution, but it will freezes at this point. Suppose this is TF. So as like that, delta TF will be TF naught. It is the difference between this temperature. Yes or no? Or we know that delta TF is directly proportional to molarity because it depends on the number of solid particles. Okay. So if you take out the proportional, we need to add constant, that is Kf here. This is known as depression constant or freezing point constant or cryoscopic constant. What will be the unit? Same, because the temperature is Kelvin kg per mole. How can it be? Kf will be delta Tf by m. Delta Tf will be your Kelvin by kg per mole. So Kelvin mole inverse, Kelvin kg inverse per mole. Okay, if you put this, you will get the unit. So next, this can be written as what? This can be written as delta Tf equals to Kf into W2 into 1000 same by M2 into W1, or M2 will be your W2 into 1000 into Kf by W1 into delta Tf. These are the equations that you have to put to get the answer. So this is your depression in freezing point. The last colligative property is your osmotic pressure. So next is osmosis or osmotic pressure. So what is osmosis? Let me tell you that osmosis is the process of flow of solvent molecules from a higher concentration region to the lower concentration region through a semi-permeable membrane. Okay, remember, flow of solvent molecules. Suppose you are taken a container and this is one funnel that you have fitted with along with a semi-permeable membrane. Suppose this is your semi-permeable membrane, this is your water, okay, and it has some solution, suppose glucose solution, okay, salt solution or glucose solution or anything. So what will happen where the concentration is more here? What concentration of solvent that is in this container? Here the number of molecules or the concentration of solvent molecule is more as compared to this. So what happens, through this semi-permeable membrane, the water molecules will get inside. And after some times, what you will observe, the level of this will increase to this. Why? It tries to equalize the concentration inside and outside. One more example I will give. This is a container and you have fitted the semi-permeable membrane, SPM. Okay, this is sugar solution. This is water, fresh water. So the concentration of solvent molecule is where is high? Obviously this side, because this is solution And solution means there must be some solute particle that will bind up the solvent molecule, so it will not so much free as compared to this. So obviously the concentration will be higher this side. So what happen, solvent molecule will come this side, and after some times the level will increase. Okay, so I hope you understood the process of osmosis. Okay, next come to what is osmotic pressure. The pressure at which you will avoid osmosis, or to stop osmosis, the pressure you are applying is known as osmotic pressure. Suppose in this case, in this case here is semi-permeable membrane and here is the sugar solution. Now the flow will come from here to here, this side to this side, but you will apply some pressure over here, external pressure. Okay, external pressure you are applying on it. And what happens? The molecules, the flow of molecules will be reduced as you are applying pressure. The molecule flow will be less time by time. But a time will come where the flow will be stopped because you are applying some external pressure over here. And that is known as osmotic pressure. Okay. If you apply more pressure, then what will happen? This osmosis will start reverse from this side to this side because the pressure is more. Though the concentration is more here, but due to the more pressure, the back flow of solvent molecule will start. Here the sugar solution will be there. Sugar molecules will be this side, but the solvent molecules will start flowing from this to this side. That is what known as reverse osmosis. Okay. So osmotic pressure, external osmotic pressure, pi, which is equals to CRT. This is again directly proportional to the concentration. So C is nothing but your N by V, RT. What is N by V? Number of moles per unit volume, that is the concentration. RT, R is the gas constant and T is the temperature. This is the concentration. Okay, so again N is, you can write W2 or W by M2 divided by number of moles. How will you calculate number of moles? Given mass by molar mass by volume into RT, which is, you can write this W2 RT by M2 V, which is your pi, or M2 W2 RT by pi into V. These are the formulas that you have to use to calculate osmotic pressure. Normally, most of questions M2 will be asking. Remember, that's why I am writing M2, the formula for M2. Okay. Remember what is osmosis, what is osmotic pressure, what is reverse osmosis. And reverse osmosis, the application of reverse osmosis is wide nowadays for purification of water. We know that Kent RO, the system they are writing RO means what? Reverse osmosis. Okay, where the contaminated water, from the contaminated water to pure water. This is how the process works. they are applying some external pressure where the solvent molecule will go from the lower concentration to higher concentration for the purification. In the foreign countries, they are not getting the drinking water, they are usually using sea water to drink. By the process of reverse osmosis, they are purifying it and they are used to take it. Okay, so again this type of solution, again the osmotic pressure, we have three type of solutions: isotonic solution, and another one is hypotonic or hypertonic. And hypotonic. From the name itself it is quite clear. Isotonic means it maintains the equilibrium. Okay, so the pressure will be same both the sides. This type of isotonic solutions, mostly our 0.9% NaCl, W by V NaCl. What is this? This solution is isotonic solution. This is nothing but your saline. Okay, isotonic. We are used to take isotonic solution in saline because the level of oxidation, suppose in hypotonic or hypotonic solution will be injected to your body, what will happen? The tissue will swell up. Okay, that's why we are giving that an isotonic solution in saline. Okay, next is hypertonic. Hypertonic is where the osmotic pressure will be high, and hypotonic means osmotic pressure will be less, very low. And the reverse osmosis is also known as diselimination solution. Okay, so reverse osmosis, osmotic pressure, osmosis. I hope you cleared these colligative properties. Okay, do the next in-text questions. Okay, the last part I'll complete today, abnormal masses. Okay, let me clear this.